Okay, let's go for today's experiment. It's gonna be Archimedes principle, and it says any object completely immersed in a fluid, water in this case, experiences an upward force. That force is called the buoyant force, right? Equals to the weight of the fluid displaced by the object. Okay, let's prove it today. We have two cases. Dealing with two objects, right, completely immersed in the fluid, and dealing with a floating object, wood. Okay, let's go to part one. In this case, we have the object finding the weight in air. Let's call this weight 1 in newtons. Now let's do the same thing, finding the weight in water. Let's call this W2, right, in newtons. The difference between these two weights is the buoyant force. Okay, so let's find the buoyant force for part A, right? Part A, case 1, correct? Gonna be weight in air minus weight in water. The answer is in newtons. Perfect. Now let's use the Archimedes principle and prove that this is correct. Okay, let's do it. So let's try it like the definition says. Let's try to weight the water displaced by the object. So let's immerse the object in the fluid. Let's catch the water. Let's find the weight displaced. Okay, the weight displaced is gonna be in newtons. And according to Archimedes' principle, the weight displaced is equal to the buoyant force. Let's prove that these two forces are the same. Actually, they're very close. Perfect. Now, and let's find the Pearson error. We have buoyant force according to Archimedes' principle minus buoyant force using this technique divided by the buoyant force according to Archimedes' principle times 100%. For this part one, we have two objects, right? And let's repeat the experiment for these two objects to make sure, right, that Archimedes' principle works. Perfect. Now let's go to floating objects. This is part 2. The same thing, we have to find the weight in air, and according to forces, Newton's second law, let's see what happens. Imagine that we have a floating object, right? It's in equilibrium. Now let's try to find the net force. Well, we need to find the forces. So we have a force going up. This is the buoyant force, and we have the weight. Correct. Now let's apply Newton's second law. The net force, correct? Net force is equals to the sum of all the forces. It's gonna be, in this case, buoyant force minus weight, and because it's in equilibrium, the net force is 0, equals to 0. Correct? From here, we can find that the buoyant force is equals actually to the weight, right, of the object in air. So buoyant force is equals to the weight of the object in air. But the buoyant force according to Archimedes' principle is going to be the weight of the water displaced. Now let's find the weight of the water displaced, and that's going to be the buoyant force, and according to this formula it's going to be the same as the weight of the object in air. Let's prove it, this part. Perfect. Again, in air it's gonna be W0 in newtons, right? Let's use experiment, the Archimedes principle experiment, right? And let's find the water displaced, finding the weight, and then that's gonna be, according to Archimedes, the same as the buoyant force, correct? And we found again that the buoyant force must be equal to the weight of the object, floating object, right, in air. Okay, let's prove that. So let's find buoyant force. We find the weight in air. Let's divide this by buoyant force times 100%. Okay, now let's give data to these quantities and try and find, right, the percent errors. Okay, let's do it. We have the object that we are gonna use for Archimedes principle. We have these two rocks, right? We have the piece of wood right here, and we have the empty can. Okay, let's try first to weight the empty can, right? We have this Newton meter, right? That give us the weight right away. Okay, let's find the weight for this empty can. Correct. You can see it right here. You see it in the camera. Okay, let's make a closer look. Okay, this is gonna be the weight. Can you see it? You see the weight? Okay, this is about what point? Oops, I'm making pressure. Okay, let me do one more time. Let's go to 0. Okay, gonna be about 0.07, right, newtons. Can you see it? Perfect. I think you can see it. Great. It says the empty can is used to catch the water displaced by the object. Now let's go to the first object, right, this one. Let's find the weight in air. Okay, let's do it. The weight in air for this object is gonna be that one. Can you see it? Okay, let me see this view. Okay, perfect. See, that's the weight in Newton, right? The weight in Newton for this object 1. Okay, great. Let me make a closer look, right? Okay, one more time. Okay, perfect. Now let's go to object 2. This is the weight in air. Okay, in air. Object 2 is this one. Perfect, it's coming. Great. Great, the same thing as before. Okay, it's the weight in air for second object. Object 2. Can you see it? Okay, closer look. Okay, one more time. Right, that's the weight in air. Perfect. Let's do the same thing for wood. Okay, let's do it. For wood, this is the weight in air. Okay, let's do it. Let's do it. For this piece of wood. Okay, let's find the weight in air. Okay, one more time. It's right there. Can you see it? Okay, there. See? Great. That's the weight in air for this piece of wood. Perfect. Now let's use Archimedes principle to find, right, the buoyant force. Perfect. Let's do it. Let's go back to object 1 one more time. Remember, object 1, we need to find the weight in air and the weight in water. Now let's go to the weight in water. Perfect. Means we have to immerse this into water. Okay, a little bit lower. I'll be completely immersed. Okay. Great. And now let's find that weight. Can you see it? That's the weight in water for object 1. Right? That's the weight in water for object 1. Yes. Okay. Weight in water for object 1. Perfect. Now let's go for object 2. Okay, weight in water for object 2. Yes, it's coming. Okay, let's do it. Let's do it. Object 2. Okay, make sure it's not touching the walls. Okay, a little bit higher. Okay, like that. Perfect. So it's gonna be again weight, second object, right, in water. Weight in water, object 2. Can you see it? Perfect. One more time. Weight in water, right, object 2. Now let's go to Archimedes principle. Remember, How we can find the buoyant force from here? Weight in air minus weight in water. That's the buoyant force. Now let's go to Archimedes principle to find the buoyant force too. Perfect. Now for Archimedes principle, correct, we use this container, right? Can you see it? Let me adjust the camera, correct. We use this container, correct. Now we are supposed to find the level of the water. Okay, let's do it. Okay, it takes for a while to find that level. Perfect, it's done. Now let's remove of the water. Correct, clean it, it's clean now. Put it back to catch the water displaced by the object. One more time, this is object 1. Right, let's try to find the weight of the water displaced. Okay, it's coming. Perfect. Now let's weight right that water displaced. To do that, remember we use the Newton meter. Okay, the balance that we have right here. Okay. Now let's find. Oops. That weight. Okay, let me remove this to make sure that you can see the Newton meter. Perfect. See, that's the weight in newtons. Can you see it? Okay, perfect. But remember, we're looking only for the water displaced. Means what? To this weight, we have to subtract the weight of the empty cap, right? The weight of the empty cap. We have to subtract that weight. Got it? Okay, perfect. This is for object 1. Let's go to object 2. Okay, one more time. Right, clean the empty cap. Correct, remove object 1 from here. Okay, and again, let's try to get the level of water the same as the opening as we did before. Correct. Okay, let's see what happens right here. One more time, let's find that level of water. Correct. Again, let's pour some water inside. Okay, to make sure that we get the level of water the same as the opening. Okay, great, almost done. Okay, now let's go to object 2. Okay, object 2, perfect. Let's remove this water, clean the cap. Right, now let's use object 2, right, and find the water displaced. Correct, by this object 2. Let's do it. Okay, great. Make this to 0. Okay, that's 0. Perfect. Okay, done. Now again, let's find the weight. Okay, let's do it. It's coming. Okay, let's put right here in the Newton meter, and that's the weight. Okay, let's adjust the camera right to see that weight. Okay, that's the weight. That's the weight in newtons. Wow, it's 1 Newton. I can't believe it. This one minus again the weight of the empty cap. Correct? Can you see it? Let me see if you can see it. Okay, can you see it? Perfect. Let's see, maybe this is better. Okay, see that's the what is placed for object 2. Great. Now let's go for the piece of wood. Okay, let's do it. One more time. Let's remove this object. Right. Again, let's go back to catch the what is placed now by wood. Okay, let's dry this cup. Okay, and that's gonna be later. Okay, now one more time. Let's find the level. Okay, let's go back right here to get the level of water. Okay, great. Perfect. Now let's clean and dry this cap, right? Okay, let's do it. And now immersed the piece of wood. Okay, it's gonna float. Okay, this is a piece of wood. Okay, piece of wood. I put it inside. Correct. And let's find the weight of the water displaced. Okay, perfect. One more time, let's use the Newton meter to find that weight. Correct. Let's adjust the camera again to find that weight. Okay, let's turn it around to see. Oops, too much. Okay, it's coming. Okay, right there. Okay, can you see it? It's like a 0.30. Okay, great. And this is again the weight of the water displaced by a piece of wood. Remember, later you have to subtract the weight of the empty cap, right, to find the weight only of the water displaced. Correct? Great. Now substitute these values on the equation that you saw before at the beginning, right, on the whiteboard, and do the calculations. Great. See you in the next experiment. Bye.